Neem Akhtar Rifat Health for All Pakistan and Problems of Pakistan and their solutions. So this channel is for their the best cause of their end life. And in the last lecture we have studied about the robotics. Let's see what we have discussed in our last lecture. So we have discussed the syllabus of the mechatronics, course outline of the basic course outline of the basic program of the robotics, and we have studied actuators, motors, and see some practical things in it, control systems. We have also studied and how to make a drone robot. And we are in the processing of this field, and I have entered the video saying later things we will discuss even in our next chapter. So first see the course outline of the first see the course. First let's have an introduction to the uh, mechatronics engineering. So these are the courses of the mechatronics engineering. These are the courses of the second semester, and these are the courses. So let's have a few basic understanding of the courses that we will studied that we will have to study in the mechatronics. Let's have some part of the introduction of it. So in the first semester we will study calculus, engineering statics, force, handles, rectangular and oblique axis movement, two and three dimension movement and resultant couple, two and three dimensional system, equilibrium, mechanical system, free body diagram, equilibrium condition for two and three dimension system structure, plant structures, the solution of plant structure with method of joint and method of section frame, and later it is the workshop introduction to sensors, switches, electronic devices, hydraulic and electric actuators, devices and mechanism used in mechatronic system theory and practice on the following fitting shop, woodwork shop, electrical shop, forging shop, foundry shop, elementary machinery shop, welding shop, PCB printed circuit board, that is the Arduino that controls all the motherboard, and PCB soldering, introduction to the computer hardware, and these are its recommended books. Later we will study the electric circuit analysis. Electrical circuit analysis, basic circuit elements, Ohm law, Kirchhoff rule, series and parallel circuit, node and mesh analysis, linearity and superposition principle, Newton laws, maximum power transfer theory, inductive and capacitive circuit, concept of circuits, reactance and impedance, natural response of first order circuit with dependent sources, response of first-order circuit to constant forcing function, response of first-order circuit to constant non-constant forcing function, complete response of second-order circuit, solving second-order circuit differential equation using Laplace transform of special signal direct transformation of circuit into S-domain as AC steady state power, concept of average power, complex power and power factor. After it is health and safety workshop, differential equations and linear algebra, engineering drawings, and it is a computer programming course, introduction to the C++, and all the basic functions of the to write a program are discussed here. So next later course outline we will discuss inshallah in our next lecture. So let's study further We have also developed there was also a folder of it, I see. Folder for the, I have included all the lectures, so let's make a new one. Leave it all where it was. Introduction, intro to robotics, intro to robotics, intro to robotics. Sensor actuators control system robotics programming. So let's see how to build a drone robot, how to build a drone camera robot. We have left it there in the last lecture, so let's see how to build a drone camera robot.
The internet is the biggest wealth creation engine to ever exist. Sadly, only a relative
So it was the concept behind a simple domain. Let's first study the principles of the remote control and later we will discuss how to make a complex robot that we can control using the automated system. So let's first study the principles of remote control. How remote control works. Control, how remote control works.
Welcome back to Curiosity Unlocked, where we explore the science behind everyday things. Have you ever found yourself in the room watching a movie, wondering how exactly the TV remote works? How did the TV know that you pressed the volume button? You might think it just simply knows, in which case you would be correct. But there's a lot more going on than meets the eye. We know that every TV remote consists of a few different buttons, such as buttons for adjusting the volume, changing channels, or just turning the TV on or off. But exactly how does pressing a button perform its exact action on the TV? Let's find out. A TV remote usually consists of three main components: the buttons, the microchip, and the infrared LED light. Let's start with the buttons. These are the interface between you and your remote. Each button is connected to a small circuit inside the remote. When you press a button, it completes the circuit, sending a signal that tells the remote what to do next. One of the most important parts inside the remote is the microchip, also known as the microcontroller. This tiny chip is the remote's brain, controlling everything from interpreting your button presses to managing the infrared signals that get sent to the TV. The microchip processes your input and then runs the necessary logic to decide which signal needs to be sent. Once the microchip figures out what signal needs to be sent, it activates the infrared LED. So, what exactly is infrared light? It's a type of light wave, just like the light we see every day, but with a longer wavelength. That means it's invisible to the human eye. For TV remotes, the infrared light typically uses a frequency between 30 and 100 kilohertz. This frequency is low enough to ensure the signal doesn't interfere with other light sources and is effective over short distances, which makes it perfect for sending signals from a remote to a TV. When you press a button, the infrared LED doesn't just flash light at random, but instead it flashes a specific pattern. You can think of it as like a digital code, each code corresponding to a certain command, such as increasing volume or switching channels. This flash is the signal, a message encoded in binary code, which is just a series of ones and zeros. Now that we've covered the remote, let's talk about the infrared sensor. This little component is located on your TV, and it's designed to receive the infrared signals sent by your remote. When the remote sends a signal, this sensor picks up the encoded message sent by the remote and decodes the binary code. After that, it tells the TV what action to take. The buttons on a remote are tied to specific commands. Each command consists of a unique sequence of binary code, basically a long string of zeros and ones. For example, pressing the volume up button might send a specific pattern, while pressing the power off button sends a different one. These patterns are like a secret code that your TV understands. Now you might be wondering, why use infrared light in the first place? Well, infrared light is perfect for remotes because it doesn't interfere with the things we see every day. Plus, infrared is easily absorbed by objects like walls, so it doesn't travel too far. This helps keep the remote focused only on the TV,